So we're going to have a look at another advanced mechanics question here. So this question says a rocket is in an unstable orbit and its altitude is gradually decreasing. How does its potential energy and kinetic energy change during the change in orbit? Okay, so let's draw a picture here. We have some mass about which the rocket orbits. It's at this altitude here, and then at some point later it's at this altitude here. So its altitude is getting lower. It starts very high and gets lower. Let's just think about these two cases in particular. Let's call this T1 and we'll call this T2. So first, what happens to its potential energy? Well, gravitational potential energy, which is what we're after in this case, this is gravitational potential energy, U is equal to minus GMM over R, where R is the distance between the two objects. So this distance here we'll call D1. This distance here we'll call D2. This could be from the objects or from the centers, depending on how you set up the coordinate system and how precise you're trying to make the measurements. So we have this. We find that if D1 is bigger, this will make one of these gravitational potential energies larger, but they're both negative, so you have to be careful about this. So we get U of D1 is equal to minus GMM over D1, and U of D2 is equal to minus GMM over D2. Now if you make the denominator of a number smaller, you make the magnitude of that term larger. So this U D2 has a larger magnitude. It has a larger magnitude. And given that these are both negative, that means this is more negative. It's a bigger number, but it's negative. So this means that the gravitational potential at D2 is less than the gravitational potential at D1. So what happens to the gravitational potential? It decreases. So gravitational potential energy decreases. So this is the first answer. So that's gravitational potential. Now we need to deal with kinetic energy. So we know, so this was gravitational potential energy. Now I've got kinetic energy. Kinetic energy, Ke, is 1/2 times mass times velocity squared. If we look at these two positions, T1 and T2, an object loses orbital altitude if it does not have a sufficient velocity to retain its orbit. So it has a particular velocity vector up here, which we'll call V1, and then it has another velocity vector down here that we'll call V2. The reason it's getting closer to the Earth, it is losing altitude. Or as the question says, the reason its altitude is gradually decreasing is it's losing speed, right? So it's getting slower as it's getting closer, as it's having its altitude decreased. And so this implies that V2 is less than V1. So we get V2 is less than V1. So we get two kinetic energies. We get kinetic energy of V1, which is 1/2 m V1 squared, and we also get kinetic energy of V2, which is 1/2 m V2 squared. Now if we know that V1 is bigger than V2, this implies that kinetic energy of V1 is bigger than kinetic energy of V2. So we get kinetic energy of V1 must be bigger than kinetic energy of V2. So what happens here? Well, kinetic energy decreases. So kinetic energy decreases. So in this case, we actually get both of these decreasing. We get gravitational potential becoming more negative and thus decreasing, and we get kinetic energy becoming less positive and also decreasing.